Okay, so for these first four problems, we're going to do them all in one video. And you can just go rewind, fast forward, or wherever you need to get to the problem so you can quickly see how it's done. So let's do the first one. So the first one is taking the square root of negative 16 over 25. Now in class we learned that we could break this up as far as the square root of negative 1 times 16 over 25. And furthermore, from Algebra 2 we learned that we can break up a square root into the following: 16 over 25, and lastly breaking it up to the square root of negative 1 times the square root of 16 over the square root of 25. We know the square root of 16 is 4 and the square root of 25 is 5, and then what we learned this unit is that the complex square root of negative 1 will come out as an I, and therefore you're left with 4/5 I as an answer. Now please do not confuse the plus or minus answers. So this is not a plus or minus 4/5 I. Okay, it's not, because the problem didn't originally say something that looked like this. X squared is equal to the negative 16 over 25. So if you have something that looks like this, whereas something is set equal to a constant squared, that's the only time that you would then take the square root of both sides, which left x on the left, and then a plus or minus answer on the right. And we already know the square root of negative 16 over 25 comes out to 4/5 I, so you would have something that looked like this. Again, that's if and only if it was set equal to a constant squared. Alright, so let's go ahead and go to part B. The square root of 81 comes out as a 9, and the square root of negative 1 comes out as I. Square root of 36 comes out as 6. Still the square root of negative 1 comes out as another I. And when we add these two together, we get 15I. So here you can treat this like a variable, like we've been doing since Algebra 1, something like 9x plus 6x. And it's just combining like terms to get 15x. But again, our variable here, or that value for the variable, is I. Alright, so let's go to number 2, part A. So I want to quickly tell you that this is not equivalent to 2 squared plus 3i squared. Okay, a lot of people think that this you distribute to both, but you only do that when only multiplication exists between these terms. Because of the fact that an addition exists here, this is duplicating a binomial by a multiplicity of 2. So when you see something that looks like this, okay, because of this addition, or there could be a subtraction there, this is supposed to be interpreted as the following. So 2 plus 3i, and then 2 plus 3i, and you are multiplying, okay, because it was a multiplicity of 2. And we know, like something like x squared, that's x times x. This has the same feeling, but because of the fact that it's this entire quantity squared, you would write the entire quantity twice. And then from here you would just FOIL out. You would multiply the first terms to get 4, and then you would multiply the outside terms, so on and so forth, to get a positive 6i. The inside terms get another positive 6i, and then the last is a positive 9i squared. Here's a common mistake, is this I squared. Make sure that you are multiplying. And I squared is very, very common as far as used in the simplification of these answers, where we know I squared is negative 1. So think of it as substituting a negative 1 where I squared is located, so that when you finally simplify, you have negative 1 here, you would get 4 plus 12i minus 9, and then you combine like terms. 4 minus 9 would give you a negative 5. So you'd write negative 5 plus 12i. That would be your answer. So these are the complex answers, and remember, those are in the form of a plus or minus bi. So please write it as such. Don't put 12i minus 5. Just get in the habit of writing it in correct complex form with your answer. Okay. So this next one, part B, is just a simple FOIL or distribution. So it'll be 1 times 5 is 5, 1 times a positive 6i. And then you distribute the negative 4i. So you'd get a negative 20i and then a negative 24i squared. So here are common mistakes. A negative times a positive is a negative. And then the other common mistake that people forget is I times I would give you I squared, which we know is negative 1. So if I were to substitute that in, it's really saying 5, a positive 6 minus 20. So it's just like positive 6 minus 20 is going to be a negative 14i. And then remember this I squared became a negative 1. And if we're subtracting that, it's a negative times a negative, which would give you a positive 24. Okay? Again, last but not least, let's combine our numeric values to get 29 minus 14i. Still remaining true with that a plus or minus bi form. Okay? So let's go ahead and erase that and make room for number 3 and 4. Alright, so number 3, erase that real quick. Number 3, something to identify immediately is there does not exist multiplication there. And because of that, you're not going to FOIL this out. You're just going to distribute a positive 1 across those parentheses where it simplifies to a positive times a negative 2i is minus 2i. Okay? So again, we did not distribute anything because it didn't have parenthesis multiplication like it did over here in the previous problem. Okay? And yes, if this was a negative right here, if it had been a negative, then it would be minus 10, but plus 2i, because you distribute a negative times a negative. Okay? Just FYI. Because that's not the case here, we're going to go ahead and finish this problem by combining like terms. I have a positive 5i minus 2i, so that I get a 3i. And then I have a 3 plus 10, which would be 13. So 13 plus 3i would be the simplified answer. Again, we are simplifying to the forms that we learned in class. Alright, let's look at part B. Part B is very similar to part A, only this time, just like we stated before, this negative distribution is about to occur. So you get a negative 12. Negative times a negative is a positive 3i. And then this just brings and carries down. The reason that it does just copy over, because there's an understood positive 1, that if I were to distribute, you would get exactly what is inside the parentheses. So combining like terms, we have a negative 7 plus 3. So we would get a negative 4i. And then 2 minus 12 would give us this negative 10. Just be careful that when you are adding, guys, that you are not accidentally trying to multiply, making this an I squared. That is a common mistake. Just we're combining like terms, just like if it would have been negative 7x plus 3x would give us negative 4x. Only again, our variable is this complex imaginary I. Alright, last ones. Okay, number 4, a little bit more involved. First, we're just going to simplify this radical of 75. And just like we talked about in class, you can do prime factorization, meaning you're going to try to divide 75 by 2, 75 by 3, and kind of break it up. Well, because it can't be divided by the first prime number of 2, you would break it up with 3. So you got 3 and 25. So if you have 3 times 25, you know this square root of 25 comes out as 5, and the root 3 stays in. So this simplifies so far to the following. We have negative 15 plus or minus 5 root 3 all over 5. Okay, the fact that I have one monomial term in the denominator of something like a summation or a subtraction, just like in 5th grade when we were adding fractions that look like this, we knew we could bring this together as one big fraction because of the fact that there was a common denominator. Okay, we're just going from here backwards. So to simplify this, let's go ahead and break it up because they share that same common denominator, and you get something that looks like the following. We are simplifying, so we're going to reduce this to a negative 3 and reduce this to a 1. So we could just write 1 times square root of 3, which is square root of 3, and there are my answers, okay? Remember, there are 2 answers that you see here. Just FYI, negative 3 plus root 3 is one of them, and negative 3 minus root 3 would be the other. But yes, you can write it just like that to account for both. Alright, so part B is close to the same as part A. The only difference is we have a negative underneath the radical. So you could break that up as negative 1 times 20. Just by prime factorization, we know we can break this up into a 4 and a 5, as well as a 2 and a 10. But the reason why I chose a 4 and a 5 is because of the fact that we can take the square root of a 4, which would come out as a 2. Okay, so negative 1 times the 5, we also know the negative 1 comes out as an I. So far it simplifies looking something like the following. 2I root 5, and it's all over 4. And just like this example where we were going backwards, because of the fact that we had one monomial, same common denominator, we know we can write this as two fractions, which are 2 over 4 plus or minus 2I square root of 5 over 4, and then just reduce the coefficients to a 1/2 plus or minus 1/2, which I'm just going to not write that understood 1, and I would get a 1/2 plus or minus I root 5 over 2. And that is it.